Hey guys, welcome to lesson 7. This is the last lesson in our unit, and we are going to be talking about applying rational equations. And so one of the first things, a lot of this is going to be word problems, so just a fair warning. But one of the first things that we're going to talk about is just solving for x. So when you have something like this, how would you get that x by itself? So a lot of times when you have a fraction, the best thing to do is just get that 3x minus 7 out of the fraction. So we are going to multiply both sides by 3x minus 7. And so I have y times 3x minus 7 equals, and then these cancel out, and so we're going to get 5x plus 2. So that makes it a little bit nicer. Let's go ahead and distribute the y. So our goal here is to get the x's together. So I'm going to move this guy over here and this term over here. So I have 3xy minus 5x equals 7y plus 2. And so what I'm doing is I'm grouping those x's together so that I can factor out an x because that's what they have in common. And so I'm going to be left with 3y minus 5. And so what happens now is I can get that x by itself when I divide both sides by 3y minus 5. So I end up getting x equals 7y plus 2 over 3y minus 5. And I am done with that problem. One more thing, we just don't forget to talk about the domain. So in this case, I'm worried about that y in the bottom, so y cannot equal 5/2. Okay, so go ahead and try this one. And we are getting y by itself. Okay, so these are my steps right here. And I just went through that same exact process, and this is my answer. And you need to make sure and find your domain, and x cannot equal 3/2. Okay, so in this case, we are getting p sub 1 by itself. So the first thing that I need to do is multiply everything by the least common multiple. So they really have nothing in common. So our least common multiple is p sub 1, p sub 2, and p. And so that's what I'm going to be multiplying each of these terms by. So when I multiply the first term by that, the p sub 1 cancels out, and I get p sub 2, p. And when I multiply this by the second term, the p sub 2's cancel out, so I get p sub 1, p. And then over here, the p's cancel out, so I get p sub 1, p sub 2. So don't forget, we are trying to isolate this p sub 1, so I'm wanting to group those together. So I think what I'll do is I will subtract both of those. So I have p sub 2 p equals p sub 1 p sub 2 minus p sub 1 p. And then just like we did before, I'm going to factor out that p sub 1. And then divide p sub 2 minus p. So this is really yucky, but it's still the same process that we've been going through. So my final answer, those cancel out, and I get p sub 2p over p sub 2 minus p. So that's about as weird as it gets. So we're going to be manipulating the distance equals rate times time formula. And you can, if you are, wanting to keep in this form, that is okay. But there's two different ways to look at the same formula. This way is just solving for r, and this way is solving for t. They both mean the same thing. They're coming from the same formula. But sometimes it's easier to look at it in, one of these forms than in this form. So it's just a helpful tip, take it or leave it. Okay, so let's go ahead and look at this word problem. And why don't you go ahead and push pause and read through it, and then I want you to grab the things that you think are important mathematically to solve this problem. Okay. Okay, so I underlined the things that I thought were important. So the distance, that's going to be the same for both of them. So I don't think that I want to focus on that. Let's keep on reading. So our average speed was 10 miles per hour less than when the reg was empty, and her return trip took an hour longer. Okay, so let's go ahead and set these equal for 2t. And the reason I'm doing that is because the distance is kind of boring. Like it stays the same for both of them. The r is being affected. So why don't we do this? Why don't we divide this by r? So the t, or the time going up, is 300 over r. And I'm going to do the same thing over here. And so the t over here is 300 over r minus 10. So this one, because her rate was slower, it took her 1 hour longer to get to where she needs to go. So if I were to put this into an equation, and I want to set like these two sides equal to each other, I need to add a +1 over here. And so that way they would truly be equal to each other. Because let's say, for example, this took us 2 hours, this took us 3 hours. If I'm going to set it equal to each other, I need that 1 for it to make sense. So I'm just going to put this all together. And then I can do the math from there. So now it just becomes a regular solving problem. So go ahead and finish it up. Okay, so I went through all of this, and sorry, I'm totally running out of room here. So all of this is just the math here, and I factored it. And so remember, we can't have a negative 50 miles per hour. So my answer is 60 miles per hour. So I want to go back and answer the question. The return trip took her an hour longer. What was her average speed? Was the rig empty? And so 60 miles per hour would be our answer. Okay, so now we're going to talk about work problems, and these show up a lot on the ACT. So go ahead and read through this problem and see what you can get out of it mathematically, just like we did before, to solve the problem. Okay, so what I grabbed out of it is if we look at this as like per hour, like how much of the job did they do per hour? And that's going to be our rate. So every hour, he gets 1/8 of the job done. And Hilda, every hour, she gets 1/6 of the job done. So if they're working together, let's see how this would work. So we have rate of Hilda, I don't know why I put her first, times time. And then we have Bill's rate times time. And that is going to equal 1 job completed. And so go ahead and do the math on this and see what you get. Okay, so I did the math and I ended up with 24 over 7s of an hour. Okay, so I want to turn that into time. So 7 goes into 24 3 times. So I know that it's 3 hours, and I have 3 7s left. So if I multiply that times 60, because there's 60 minutes in an hour, I get 25.714, blah, blah, blah. And so I'm just going to round that up to 26 minutes. And so I get 3 hours, 26 minutes. Okay, so this is very similar to the one we just did. So go ahead and see if you can do this. So this one is a little deceiving the way it's worded. So I just want to kind of clarify some things. So we're going to set it up the same way. We know that Linda can work by herself 1/4 of an hour. We don't know how long it would take Rebecca doing it by herself. What we do know is that together it takes them 3 hours. So this T right here, we already know that. That's 3 hours. So we're going to set it up as like that. And then do the math from there. Okay, so we end up with 12 or x equals 12. And so what that means is that if Rebecca was doing it by herself, it would take her 12 hours to complete the job. Okay, now we're going to do unit price, and this is just a little bit different. So we're going to look at it instead of like a rate, we're going to look at it as price per pound, and then times the amount is equal to the total price. Okay, so go ahead and grab what you think is important from this. Okay, so there is a lot going on here. So let's go to like the definition. So I'm just going to look at the hamburger. So the hamburger is worth $30 per pound, but I don't know how many pounds of hamburgers we have. The steak is $90 per pound. I don't know how many pounds of steak I have. So what I'm going to do is I'm just going to tag one as X and one as 50 minus X. And that's going to tell me that total I have 50 pounds, and so it'll kind of work itself out. Something else I want to point out is this one, that the steak costs twice as much per pound as the hamburger. So if I'm going to set that equal, I'm going to say that for every pound of steak, I need 2 pounds of hamburger. And so what I'm going to do is I'm going to turn this into a math equation using that concept. So it looks like that. So go ahead and do the math for that, and then we'll answer the question. Okay, I ended up getting x equals 20. So let's see what that means. How many pounds of each did he buy? Well, I know that, so let's go back. I tagged x as a hamburger. So I know that he bought 20 pounds of hamburger. And then the steak, it's what's left over. So 50 minus 20 is 30 pounds of steak. Okay, so this is our last problem. See what you can do with that. So sorry, this is the same problem, just a different way of looking at it. So instead of like multiplying these two together, you could divide both sides by the amount and put the amount over here. So that's what I did here. And I kept this the same. That's going to be the exact same. And so if you'll notice, the question is different. That's the only thing that's different about it. So then what was the price per pound for meat? So if we look at it as price per pound, this is really easy. So you're just going to take 30 divided by the number of pounds for the hamburger, which was 20. Sorry, that's here. And then 60 over 30. So the price per pound for the hamburger, if I simplify that, that would be $1.50 per pound. And then over here, sorry, that was 90 on top. 90 divided by 30, that's going to be $3 per pound. And so that's it. So we did the majority of this problem. It's just like a different kind of way that it's worded. Okay, and that's it, guys.